In this example, we would like to find dy dx if x squared plus y squared squared is equal to 50xy. And this equation has a graph that looks a little bit like a figure 8, kind of sideways here, like that. It's what's called a lemniscate, and dy dx will tell us the slope of the tangent line to the lemniscate at any point. The method for finding dy dx is implicit differentiation, and in order to use implicit differentiation, we assume that y is a function of x. And the picture clearly shows that that's not the case. This figure 8 does not pass the vertical line test, and so this figure 8 is not globally a function of x. But when finding the derivative, the slope of a curve at a point, we don't actually need all of the points on the curve. You just need some of the points near the point of tangency. Well, you need all of the points near the point of tangency. So you just need a section of the curve, and it's reasonable to assume that a section of the curve is a function. So we assume y is a function of x, and then the computational method is to take the derivative with respect to x of both sides of the equation. So the derivative with respect to x of the left side equals the derivative with respect to x of the right side, and then if we do this differentiation correctly, the symbol dy dx should be involved in the result. So let's see here. In order to calculate the derivative on the left side, I'm actually going to square this out. X squared plus y squared, quantity squared using the FOIL method. I have x squared plus y squared times itself. And if you use the FOIL method, you'll end up with x to the 4th from the outside plus 2 times x squared y squared from the outside and the inside, and then plus y to the 4th from the last. And that should equal the derivative of 50xy. Now let's start computing these derivatives. What is the derivative of x to the 4th? That derivative is 4x to the 3rd. And the derivative of 2x squared y squared, that requires the product rule. The first function is 2x squared. The second function is y squared. So the product rule says the first times the derivative of the second, which from the chain rule is 2y times dy dx, plus the second, which is y squared, times the derivative of the first, which is 4x. And then plus the derivative of y to the 4th from the chain rule is 4y cubed times dy dx. And on the right, the derivative of 50xy, this requires the product rule because 50x is the first and y is the second. So we have the first, which is 50x, times the derivative of the second, which is dy dx, plus the second, which is y, times the derivative of the first, which is 50. Okay, so we have this pretty big, clunky equation here, which does have the expression dy dx in it. And so to get our answer, we will solve this equation for the expression dy dx. So we will solve this for dy dx. So first we'll take the dy dx terms and put them all on one side. There are already 2 on the left side, so we'll move this 50x dy dx that's on the right over to the left. So we have 4x squared y times dy dx plus 4y cubed times dy dx minus 50x times dy dx is equal to, now on the right side we'll put everything else. There's already 50y on the right side, And now we'll move the 4x cubed over, so minus 4x cubed, and we'll move the 4xy squared over, so minus 4xy squared. And now we factor dy dx from the left side, so we have dy dx times 4x squared y plus 4y cubed minus 50x is equal to, and copy the right side, 50y minus 4x cubed minus 4xy squared, and finally divide by the quantity in the parentheses, so dy dx is equal to the right side on the top, 50y minus 4x cubed minus 4xy squared divided by the quantity in the parentheses goes on the bottom, 4x squared y plus 4y cubed minus 50x. Now we could factor a 2 from the numerator and a 2 from the denominator, and they'll cancel. So factoring and canceling a 2, we get 25y minus 2x cubed minus 2xy squared on the top, and we get 2x squared y plus 2y cubed minus 25x on the bottom. So there is our derivative, and that is the slope of our lemniscate at any point xy on the lemniscate.